Hello 8th grader, I hope all of you in a good condition right now. Today we are going to learn about force, and especially through the video we will learn about the resultant of forces.
The basic competence of this lesson is to analyze the straight line motion, the effect of force on motion based on Newton's law, and its application to the motion of the object and the motion of living things. The resultant of a line force. The several forces acting on the body can be replaced by a force called force resultant or resultant of force or net force, and the symbol is R. For mathematically, the magnitude of force resultant or R is expressed as follows: R equals to F1 plus F2 plus F3 plus etc. And the important thing is, to simplify calculation, give positive sign, plus for the force direction to the right or upward, and negative or minus for the force directed to the left or downward. If the forces are in the same direction, combine two forces acting upon the object, add both forces together, and keep the direction the same. Next, example forces in the same direction. Two children to be pushing in the same direction. If one child pushed to the right with the force of 30 Newton, and the other child also pushed to the right with a force of 15 Newton. Look at the picture. This is the box pushed by two forces, F1 and F2. F1 30 Newton and F2 50 Newton with the same direction. And the black vector is the resultant of forces or R from this problem. To find R, because F1 and F2 in the same direction, so F1 plus F2, 15 Newton plus 30 Newton, so the reaction is 45 Newton, and the direction is the same with the direction of F1 and F2 toward to the right. If the forces are the opposite, find the difference between the two forces acting upon the object. Subtract the smaller force from the larger one. Keep the direction of the larger force. Example for the opposite force. 1. If a child puts the block with a force of 100 Newton toward the right, and the other puts the block with a force of 60 newtons toward the left, so we can find that the result of force will be 40 newtons size and directed toward the right. This is the block pushed by two forces, F1 100 Newton to the right and F2 60 Newton to the left. This is the illustration. The black vector is the resultant of forces or R from this problem. To find R is F1 plus F2. F1 is 100 Newton and F2 is minus 60 Newton because the direction of F2 is to the left. And the answer is R equals to 40 Newton and the direction is plus or toward the right because the larger one is F1 to the right. Example 2. Two children pushing on the block with the same forces. One person pushing toward the left with a force of 40 Newton and the other pushing toward the right with a force of 40 Newton. So what is the net force on the block? This is the block. The block pushed by two forces, F1 to the right 40 Newton and F2 40 Newton to the left. This is the illustration. From the formula of resultant of force, R equals to F1 plus F2. 40 Newton plus minus 40 Newton because F2, the direction is to the left. So we can find the resultant of force is 0 Newton. It means the object will not accelerate, so the velocity of the object will not change. Example 3. There are two vectors of forces, F1 8 Newton to the right and F2 2 Newton to the left. So find the magnitude and the direction of the resultant forces F1 plus F2. Draw the vector of F1 8 cm to the right because the scale is 1 Newton equals to 1 cm. And draw F2 2 cm to the left, and the red vector is the resultant. Number 2. F1 minus F2. Draw the vector of F1 8 cm to the right, and then draw F2 2 cm to the right because F2 2 Newton to the left, so minus F2 is 2 Newton to the right, and the red vector is the resultant. Number 3. F2 minus F1. Draw 2 cm of F2 to the left and draw 8 cm F1 to the left because F1 8 cm to the right, so minus F1 is 8 cm to the left, and the red vector is the resultant. Now the magnitude and the direction for each resultant. Number 1. 8 Newton minus 2 Newton, so the answer is 6 Newton to the right. Resultant 2. 8 Newton minus 2 Newton, so the answer is 10 Newton to the right. Number 3. R equals to minus 2 Newton minus 8 Newton, so the answer is minus 10 Newton or 10 Newton to the left. Next, resultant of non-aligned forces. Non-aligned forces are the forces that are not parallel to each other, but they form a certain angle. There are three types of method to calculating non-aligned forces. 1. Parallelogram method, tail-to-tail method for two forces. 2. Triangle method, head-to-tail method for two forces. And 3. Polygon method, head-to-tail method to add more than two forces. And this is the part of vector, this is tail, and the arrow is head. Example. There are three vectors of forces, F1 8 Newton to the right, F2 2 Newton to the left, and F3 12 Newton with the angle is 30 degrees. Draw the resultant of forces F1 plus F3 by using parallelogram and triangle method. 1. F1 plus F3 by parallelogram method. Draw the F1 8 cm to the right, and then draw F3 with the tail of F1 to the tail of F3, and the angle between F1 and F3 is 30 degrees, and the length of F3 is 12 cm. Draw the image vector of F1, and then draw the image vector of F3 with the same size and the same direction, and the red and the diagonal line is the resultant. Next, by triangle method. Draw the F1 8 cm to the right, and draw F3 with the tail of F3 to the head of F1, and the resultant is the line from the tail of F1 to the head of F3. The red vector is the resultant. Now the resultant of forces F1 minus F3 by parallelogram and triangle method. By parallelogram, draw F1 8 cm to the right, and then draw 12 cm of minus F3 to the bottom with the tail of F1 to the tail of F3, and then draw the image vector of F1 and the image vector of F3 with the same size and the same direction, and the diagonal line or the red vector is the resultant. Next, triangle. Draw F1 8 cm to the right, and then minus F3 12 cm to the bottom with the head of F1 to the tail of F3, and draw the resultant of from the tail of F1 to the head of F3, so the red vector is the resultant. Next, the resultant of forces F3 minus F2 by parallelogram and triangle method. By parallelogram, draw F3 12 cm to the top, and then minus F2 to the right because F2 to the left, so minus F2 to the right, with the tail of F2 to the tail of F3, and then draw the image vector of F2 and then the image vector of F3 with the same size and the same direction to the original force, and then the diagonal line or the red vector is the resultant. Next, by triangle, draw 12 cm F3 to the top, and then draw minus F2 to the right with the head of F3 to the tail of F2, and then draw the resultant of force from the tail of F3 to the head of F2, so the red vector is the resultant. Next, there are 4 vectors, F1 8 Newton to the right, F2 2 Newton to the left, F3 12 Newton to the top with the angle is 30 degree, and F4 6 Newton to the top with the angle is 45 degree. Find the resultant of forces F4 minus F3 by parallelogram and triangle method. By parallelogram, draw the resultant of F4 6 cm to the top, and then F3 12 cm to the bottom, with the tail of F3 to the tail of F4, and then draw the image vector of F4 and then the image vector of F3 with the same size and the same direction to the original force, and then the diagonal line or the red vector is the resultant. Next, triangle. Draw the vector of F4 to the top and minus F3 to the bottom. Because F3 to the top, so minus F3 to the bottom. Draw the resultant of forces from the tail of F4 to the head of F3, so the red vector is the resultant. Next, the resultant of forces F1 plus F3 plus F4 by polygon method. First, draw the vector of F3 12 cm to the top, and then vector F4 6 cm to the top with the head of F3 to the tail of F4, and then draw F1 8 cm to the right with the head of F1 to the tail of F3, and then draw the resultant of forces from the tail of F1 to the head of F4, so the red vector is the resultant. Next, the resultant of forces F1 minus F3 minus F4 by polygon method. First, draw the vector of minus F3 12 cm to the bottom, and then vector F1 8 cm to the right with the head of F1 to the tail of minus F3, and then draw minus F4 6 cm to the bottom with the head of minus F3 to the tail of minus F4, and then draw the resultant of forces from the tail of F1 to the head of F4, so the red vector is the resultant. I think that's all for me. Thank you for your attention and God bless you.